Alright, so let's go ahead and take a look at Lesson 7.1, Ratios, Proportions, and Radicals. A ratio is a comparison of two quantities using division. We can express ratios in multiple ways. We can write this as A to B, we can write this as A colon B, or we can write this as A divided by B, where B cannot be 0. And the reason why B cannot be 0 is you don't want an undefined answer. So these are the three ways that you can write a ratio. Now, something to know about ratios is that ratios must be reduced. Ratios must be reduced. So, if I were to say 1 over 2, this is a ratio, and it's reduced. So our 1 to 2 ratio is good. But if I were to say 2 over 4, our 2 to 4 ratio, well, you know that we can simplify 2 over 4. We just need to know what is the highest number that goes into 2 and 4 at the same time. Well, that's just going to be 2, right? 2 goes into 2 and 2 goes into 4. So I can divide the top and the bottom by 2, which is going to be 1 over 2. So when I said 2 to 4, I really mean 1 to 2. So remember, the ratios must be reduced. In the real world, we use ratios a lot. We use them for cooking, we use them for shopping, we use them for cost, and we can, use it for a lot of things. If I were to say a player scores 20 goals in 25 games, well, that's a 20 to 25 ratio. So it's going to be 20 to 25, or 20 colon 25, or 20 over 25. But again, remember, ratios must be reduced. So instead of saying, 20 goals in 25 games, I can reduce the fraction here. I can reduce this ratio here. Well, what's the highest number that goes into 20 and 25 at the same time? Well, I'm thinking 5. So I need to divide the top and the bottom by 5, and that's just going to be 4 over 5. So, instead of saying 20 goals in 25 games or 20 to 25, I can actually say 4 to 5, which is my reduced ratio. So this just means that the player scores 4 goals for every 5 games. So it's a 4 to 5 ratio. Now, an extended ratio is used to compare 3 or more quantities. We can write this as A to B to C, right? I'm comparing 3 quantities. Or if you want to go further than that, you can say A to B to C to D. This is where I'm comparing 4 quantities. If you wanted to compare 5 or 6 to 7, then you need more than what we have here. Okay? So let's take a look at our first example that deals with extended ratios. Example 1. The ratio of the measures of the angles in a triangle is 3 to 4 to 5. So this 3 to 4 to 5 is an example of an extended ratio. Find the measures of the angles. So we need to slow down and take a look at what we're dealing with here. Number 1, we're dealing with a triangle. Number 2, we're dealing with angles of that same triangle. And number 3, our ratio of the measures of the angles in this triangle is 3 to 4 to 5, which is our extended ratio. Our goal here is to find the measures of the angles. Now, this 3 to 4 to 5, I can go ahead and put that on the triangle here. This is going to be 3, this is going to be 4, and this is going to be 5. But the problem here is if I added all these numbers, 3 plus 4 plus 5, that's going to be 12. But remember that the sum of the interior angles of a triangle is 180 degrees. This is not 180, so something is going wrong. What I need to do is I need to put something right next to each of these numbers here. We're going to put a variable, and we're going to use x, right? So x goes right next to this 3, x goes right next to this 4, and x goes right next to the 5. And this is perfect because I can actually create an equation here. So I have 3x plus 4x plus 5x, and what is that going to equal to? Well, I'm creating an equation, and we know that the sum of the interior angles of a triangle is 180 degrees. Okay? So 3x plus 4x plus 5x, if I were to add these numbers, I'm going to get 12. 12 what? 12 x's, which is equal to 180 degrees. Now, I'm going to divide both sides by 12 here because I want to get x by itself. So I'm going to get x equals 15. So x is 15, and what I'm going to do now is I'm going to substitute. So if I were to replace each of these x's with 15, well, 3 times 15 is 45, so 3 times 15 is 45 degrees, and over here 4 times 15 is 60 degrees, and lastly 5 times 15 is 75 degrees. Well, these are my answers, and this is going to turn into a 45 to 60 to 75 extended ratio. Okay? And here's the thing. What you can do is you can check your work. I have my 45, 60, and 75. This is my extended ratio. And here is that 15, that x value that we found earlier. I can divide each of these numbers by 15 to check my work. So I can divide this by 15, that by 15, and that by 15. And what is that going to give me? Well, 45 divided by 15 is 3, 60 divided by 15 is 4, and 75 divided by 15 is 5. So 45, 60, and 75 degrees. Here you go, that's your answer. Example number 2. The ratio of the length and the width of a rectangle is 5 to 2. So this ratio is 5 to 2. That's the ordinary ratio that we talked about at the beginning. Right? We're comparing two quantities. We're comparing the length and the width of this rectangle. Now, the perimeter of the rectangle is 112. Find the measure of each side. Now, perimeter just means the total distance around the figure. If you remember or recall from elementary or middle school, you learn that when you have perimeter, you're just adding up all the sides, which is completely true. But just know that the perimeter just means the total distance around the figure. So let's go ahead and use this opportunity to draw our rectangle. Here's my rectangle. This is the length, and this is the width. Remember, our ratio is 5 to 2. So this is our length, and this is our width, and we're dealing with a ratio. So again, this is the length, this is the width. I'm going to write 5 here, 2 there. Okay? But just like example number 1, we don't just put 5 and 2. We actually have to put, a variable right next to them. So I put an x here and an x there, and I'm going to use this formula that I have here. The perimeter formula for a rectangle is 2 times the length plus 2 times the width. So we actually know what the perimeter is. That's 112, right? So I'm going to replace P with 112, which is equal to 2 times, what's the length? It's 5x, plus 2 times the width, which is 2x. So then I have 112 equals 2 times 5x is 10x, plus 2 times 2x, that's 4x. I can go ahead and combine these two terms here, which is 14x, right? So then if I divide both sides by 14, you're going to get x equals 8. So if x equals 8, then that means that I can do 5 times 8, which is 40. And then I have 2 times 8, which is 16. So our answers are 40 and 16. Now, do I need to use this formula? No. I can just say 2x plus 2x plus 5x plus 5x equals 112, and you should get the same thing, right? If you remember back in Unit 6, we talked about rectangles. A rectangle is a parallelogram, and remember, a parallelogram, opposite sides are congruent. So if this is 2x, this is 2x. If this is 5x, this is 5x. Just add up all the sides there and set that equal to your perimeter, which in this case is 112. So now what we're going to do is we're going to look at more vocabulary words. Starting off with a proportion. A proportion is an equation stating that two ratios are equal. And let me give you an example of what that means. Suppose that I give you a ratio 2/4. And that's going to equal to another ratio 4/8. So the 2/4 equals 4/8. They are equal to each other, therefore they are proportional to each other. And let me go ahead and just verify that this is the case. I'm going to look at this 2/4 here. I'm going to write 2/4 on the side over here, and I'm going to reduce this. What is the highest number that goes into 2 and 4 at the same time? Well, it's going to be 2. So I write 2 here and 2 there. I'm dividing the top and the bottom by 2. And that's just going to give me 1/2. So this 2/4 reduces to 1/2. And now I got to do the same thing for this 4/8. So this 4/8, what is the highest number that goes into 4 and 8 at the same time? Well, that's just going to be 4. So that means I need to divide the top and the bottom by 4. 4 divided by 4 is 1, and 8 divided by 4 is 2. So this 4/8 reduces to 1/2 as well. So what does this all mean? It means that the left-hand side of the equation is equal to the right-hand side of the equation, meaning that these two ratios are equal to each other, therefore they are proportional to each other. Hopefully that makes sense. Now, what we're going to do is we're going to talk about cross products. Now, before we do that, we need to define what the means and the extremes are. I'm looking at this picture here. We have A divided by B, which is equal to C divided by D. So here in blue, these are the means. So B and C are the means. And then these two things here in red are the extremes. So that's A and D. So you probably have heard of something called cross multiplication or the cross products. We say that the product of the means equals the product of the extremes. Basically, you're cross multiplying. You probably have heard of the butterfly method or the baseball method or whatever. Essentially, you're just multiplying A times D. So A times D is equal to B times C. B times C. And that's just cross multiplication or the cross product. Alright, so example number 3, we're going to solve each proportion. So when I'm solving each proportion, you can use that baseball method or butterfly method, but really what you're doing is you're cross multiplying. I'm looking at number 1. I have 6 over x equals 21 over 31.5. We're going to cross multiply, so I'm going to multiply the 6 and the 31.5. And that's going to equal to the 21 times x. So 6 times 31.5, that's 189, equals the 21 times x, which is 21x. Now looking at this, this is just an ordinary algebra problem. So I got to just solve for x here. I'm going to divide both sides by 21, so x equals 9. Okay, and that's it. You're just solving for the variable. I was using proportions to do that. So x is equal to 9 for number 1 here. For number 2, I have x plus 3 divided by 2, which is equal to 4x divided by 5. So what I'm going to do is I'm going to multiply the 2 and the 4x. So 2 times 4x equals the 5 and the x plus 3. So here's the thing. You don't write 5 times x plus 3, right? You have a number multiplied by an expression here. You do not write 5 times x plus 3. What you need to do is you're going to write the number, and since you're multiplying this number with this expression here, you have to put the parentheses. So it's 5 times the quantity x plus 3. Okay? Now, let's just do the easy part here. 2 times 4x is 8x, which is equal to, and then this is where I need to apply the distributive property. So that's 5x plus 15. Now we need to move that 5x, right? And what we need to do, what do we have to do? Well, we have to subtract both sides by 5x here, right? That's just going to give me 3x equals 15. And then that's just going to be x equals 5. So our answer for number 2 is x equals 5. Alright, so let's go ahead and move on to number 3 here. So again, we're going to cross multiply 4 times x, that's 4x. And then that's equal to 6 times the quantity of x plus 5. And then distribute, so you have 6x plus 30, and don't forget the left-hand side is 4x. Now, I'm going to subtract both sides by 6x here, So I have negative 2x, because 4x minus 6x is negative 2x, equals 30. Then let's divide both sides by negative 2. So x is equal to negative 15. And that's my answer. Now what we're going to do is we're going to flip to the back side of the notes. We're going to learn how to simplify radicals. Now before we do that, we need to talk about perfect squares and square roots. A perfect square is the product when a number is multiplied by itself. If I look here, I have x times x. The x is multiplied by itself here. So if I said x times x, I can rewrite that as x to the second power. So x to the second power, we consider that a perfect square. We can also say the same thing with 5. If I have 5 multiplied by itself, that is just 5 to the second power. 5 to the second power, or 5 times 5, is 25. We say that 25 is a perfect square of 5. I can also say the same thing for 3. 3 times 3, where 3 is multiplied by itself here. 3 times 3 is another way of saying 3 to the second power. Or you can just say 9. So 9 is a perfect square of 3. In table of perfect squares. So x times x is x to the second power. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and so on and so forth. And it's best that you know your table of perfect squares. Now, let's talk about a square root. A square root is a value that when multiplied by itself, it gives the original number. If I were to take the square root of a perfect square, well, here's the thing. The square root and that 2, they will go away, and you're left with what's left over, right? That's going to be x. If I take the square root of 25, well, here's the thing. The square root of 25, I can rewrite the 25 here as 5 to the second power. So basically, you're taking the square root of 5 to the second power. Again, the square root and the 2, they don't like each other. They are, basically inverses of each other. They will go away, and you're left with that 5. So the square root of 25, or the square root of 5 to the second power, is just the 5. So 5 is the square root of 25. Okay? All right, so let's look at the bottom of our notes. We're going to review how to simplify radicals, and there are multiple ways on how to simplify radicals. Method number 1, look at the largest perfect square factor. Divide the radicand. Now, radicand just means the number under the square root. Divide the radicand by the perfect square smaller than it until you find one that is a factor. Then, take the square root of the perfect square and leave the other factor under the radical. So I'm looking at the square root of 75. I need to think of 2 numbers that multiply together where one of them is a perfect square. Well, I'm thinking of 25 and 3. Note that 25 is a perfect square, and it's multiplied by just another number. So 25 times 3 is 75. Now, I can take the square root of 25 times 3 and rewrite that as the square root of 25 times the square root of 3. But y'all, we know that the square root of 25, that's 5, right? So what happens is if I can take a square root of something, it's going to go outside of the radical here. So the square root of 25 is 5. And the square root of 3, well, we can't take the square root of 3, so it's just going to be left alone. You don't do anything there. So your answer is 5 times the square root of 3. Now let's take a look at method number 2. Use a factor tree and look for pairs of factors. Now break down a number into its factors. Circle each pair of numbers and underline any numbers that do not have a pair. For each pair, bring out one of the numbers and multiply it with any other factors that come out. Then multiply all the underlined numbers back together and the product will remain under the radical. So let's take a look at the square root of 128. What I like to do is draw my caret sign because we're dealing with a factor tree. Now, here's the thing with this caret sign. I need to think of two numbers that multiply together that'll give you 128. Now, with one of these two numbers, I like to have one where it is a perfect square. And I'm thinking 64 and 2. 64 times 2 is 128, and this 64 is a perfect square. 64 is a perfect square of 8 because 8 times 8 is 64. Okay? So now what I need to do is I need to keep on going with my factor tree. I can break down this 64. The two numbers that multiply together will give you 64 is 8 and 8. Okay? And this is great because, look, we have a pair of the same number. We have a pair of 8. So what I need to do is circle them and just not go further than that. Okay? Now with this 2, are there two numbers that multiply together will give you 2? Yes, 1 and 2, but that's pretty much it. You really can't break that down because you're going to go in an endless cycle, which you don't want. So just leave the 2 alone. We're going to underline that too. Now, to form the answer here, we're going to have our square root drawn out. And looking at the pair of 8s that we have here, one of the 8s is going to go outside of the square root and the other one is just going to go away. So this 8 is going to go outside. So it's going to go outside of the square root here, and this 8 is going to go away. We don't need it anymore. Now with this 2, since it didn't have a little buddy, it didn't have, or I should say that we didn't have a pair of 2s, well, this 2 is actually going to go under the radical. So your answer is 8 times the square root of 2. Okay? Now, what I want to do is I want to show you another method. You can do this if you totally like. It's basically combining the two methods together. You're using the factor tree method, and you're using that square root method as well. So let's say I give you the square root of 50. Now, the square root of 50, I'm going to do my factor tree. What are the two numbers that multiply together to give you 50, where one of them is a perfect square? I'm thinking 25 and 2. 25 is a perfect square and 2 is not. So what I like to do now is I'm going to draw a square root for each of these two factors here. The square root of 25, we know that is just 5, and the square root of 2, well, you can't take the square root of 2, so you leave it alone. So it's going to be 5 times the square root of 2, and that is your answer. Okay? Now, let's say that you did this problem and your two numbers aren't perfect squares. So what I'm trying to say is if you have the square root of 50 and your two numbers are 10 and 5, you know that 10 isn't a perfect square and 5 isn't a perfect square. What do? Well, you have to keep on breaking these numbers down if you can. The 10 here I can break down with 5 and 2. And this 5 is, well, you can't break that down. You're going to get 1 and 5. 5 is a prime number. So, here's the thing. You have a pair of the same number. You have a pair of 5s. So I'm going to circle them. And then this 2, it's a prime number. You can't even, you can't break that down. That's going to get underlined. So then, what do? Well, you're going to form your answer. You're going to draw your little square root. And since you have a pair of the same numbers, one of the 5s will come out. And the other one is going to get eliminated. Okay? And then that little 2 is going to go under the radical. So your answer is 5 times the square root of 2. Alright, so let's take a look at these examples here. Our first example is the square root of 50. But we've already done that problem already over here. The square root of 50 is 5 times the square root of 2. So we're going to go ahead and move on to the square root of 48x squared. Now, here's the thing. We have a number multiplied by this variable here to the second power. We have, two different terms multiplied together. Now, what I like to do is I'm going to break them up. So I have 48 here and x squared there. Okay? So let's go ahead and figure this out. I'm going to break down the 48. I need to think of two numbers that multiply together where one of them is a perfect square. That'll give me 48. And I'm thinking 16 and 3. Okay? So 16 is a perfect square and 3 is not. So now what I want to do is I'm going to take the square root of the 16, the square root of the 3, and the square root of x squared. And y'all, I know that x squared is a perfect square, right? We've already established that right over here. X squared is a perfect square of x. So then I'm going to figure out what the square root of 16 is. The square root of 16 is 4. The square root of 3 is just the square root of 3. So that's just going to go under the radical here. And the square root of x squared is just x. And that's just going to go outside of the square root sign here, right? So it's going to be next to the 4. So then it's just going to be 4 times x, which is 4x root 3, and this is your answer. Alright, so let's go ahead and move on to this problem here. 5 times the square root of 84, x to the 4th times y to the 2nd. I'm going to use method number 1 here, look for the largest perfect square factor. So here's the thing. You need to remember that 5 is outside of the square root, and this is very, very important to note, okay? So 5 is going to be outside of the square root, and then here I can just go ahead and rewrite this as 84 times x to the 4th times y to the 2nd. All right? So here's the thing. I have 5 outside of the square root, and this 84 I can break down. I need to think of two numbers that multiply together that will give you 84, where one of the factors is a perfect square. And I'm thinking 4 and 21. Okay? 4 is a perfect squared, and it's going to get multiplied with the 21, which will give you that 84. And then here I know that x to the 4th power is a perfect square. So if you have a variable raised to an even numbered power, that's always going to give you a perfect square. Okay? So x, if I take the square root of x to the 4th power, that's essentially the square root of x to the 2nd times x to the 2nd, or your answer is x to the 2nd power. So you just basically take this, divide by 2, and you get x to the 2nd. If you have the square root of x to the 6th power, you can just say that it is x to the 3rd power, and that's your answer. Okay? That's my little side note. And then you have times y squared here. All right, so now what I need to do is I have this 5, and I'm going to take the square root of 4. So it's the square root of 4, that's going to be 2. So 2 is going to go outside of the square root sign. And then, can I take the square root of 21? No, that's actually going to go under the radical. It's going to remain inside of the radical sign. Here's the square root of x to the 4th. Well, it is an even numbered power, so I can just do 4 divided by 2, right? And that's just going to give you 2. So the answer here, or not the answer, but what we're supposed to write here is x to the 2nd power. And then lastly, we have the square root of y to the 2nd power. You have a variable raised to the 2nd power, so you can just do 2 divided by 2, and that's just going to give you y to the 1st power, or just y. So then, let's put it all together here. 5 times 2 is 10, x squared times y, root 21, and that is your answer. Okay? All right, let's do the same thing for this one here. Remember that anything outside of the radical you have to take into consideration because you're going to be multiplying with the other numbers that come out. So I have 2 root 261 times z. And what I like to do is, again, I need to write 2 here, and I need to figure out, okay, what 2 numbers multiply together will give you 261, where one of them is a perfect square. That's just going to be 9 times 29. And if you're having a hard time, figuring out what numbers multiply together where one of them is a perfect square, take this number and just divide by these perfect squares. Now, of course, you don't want to use 1. You want to start with 4, and if if 261 divided by 4 gives you a whole number, then use that perfect square and that whole number to multiply. If it gives you a decimal, however, then you need to keep on going forward. Okay? So in this case, you can do 261 divide by this perfect square, and that's going to give you 29. Now, 29 is not a decimal, so that means you can work with those 2 numbers, the perfect square and the result, to get you that number. Okay? So 9 is a perfect square multiplied by 29, that's 261, and then don't forget we have that little z. Okay? All right. So 2 times the square root of 9, that is going to be 3. So 3 is going to come outside of the radical, times the square root of 29, which you can't take the square root of, so that's going to go under the radical. And then the z, taking the square root of z there, that is not a perfect square, so it's going to remain under the radical with the 29 there. So it's going to be 29 times z. Okay, so you're separating those things with the multiplication sign, just like what we did outside of the radical here. 2 times 3, that's just going to be 6. Root 29 times z, that's 29z, and that's your answer. Okay, so I'm going to make this part of the video so that hopefully I am answering your questions, even though I can't hear you ask your questions. I just want to make sure that we all understand how to do the factor tree method, which is method number 2. Now, I'm going to go ahead and look at the square root of 24. Now, I told you that with your factors, you can use 2 numbers that multiply together. That'll give you this, where one of them is a perfect square. Well, I'm thinking, let's say 6 and 4, okay? 6 times 4 is going to give you 24. And 4 is a perfect square, which is great. So then, what I can do is I can break down that 4, and that's going to give me 2 times 2, okay? So I'm going to circle the pair of 2's, and you're just going to hold on and look at this number 6 here. The 6, even though it's not a prime number, you can break this down and you get 3 and 2. Okay? Now look, I have a 3, I have a 2, the 3 is prime, the 2 is prime. You can't break down the 3. The only numbers that multiply together that'll give you 3 will be 1 and 3. And for the 2, it's also a prime number. The 2 numbers that multiply together will give you 2 are 1 and 2. Okay? So what are you going to do with 3 and 2? We're going to go ahead and underline those 2 numbers. So now let's go ahead and create our answer. You're going to draw the square root sign. You're going to look at the pair of 2's. You know for sure that one of the 2's will come out and the other one is going to go away, right? So the 2, this 2 is going to go outside of the square root, and this 2 here will go away. But what about the 3 and the 2 here? Well, since we don't have a pair of 3's and we don't have another pair of 2's, these 2 numbers will go inside of the radical and they will get multiplied. So you're going to write 3 here. Okay, so you don't need this anymore. You don't need this 3 anymore. And this 2 is going to go right next to the 3 under the radical. So make sure that you multiply, or you have some sort of separator. Well, the separator is going to be the multiplication sign. So it's going to be 3, and you're going to separate that and put a 2 next to it. So now you're going to simplify your answer. It's going to be 2 times the square root of 6. Now, here's the thing. You did not have to break down this 6, right? Because, first of all, you can't take the square root of 6. Since you can't take the square root of 6, you just leave it alone. You can take the square root of 4. So what's the square root of 4? It's 2. Therefore, 2 is going to go outside of the radical. Okay, so hopefully this makes sense.